Dear students, this lecture is about the rectangular hyperbolic functions and their economic applications. Let's get started. As you can see that the rectangular hyperbolic function has its etymology. We have to understand how this word is composed. Basically, it's a composition of two words. One is hyper, which means beyond, and the other is bola, where bola means to throw. So this Latin set of words explains us that it is a throw which is beyond. Now, what is the meaning of beyond in it? Beyond here means that in case of parabola, the word was para, which means beside. So, as compared to parabola, we are throwing beyond. And that is also visible in this diagram, where you can see the parabola. If a ball, for example, follows the path of parabola, it will go to a certain distance. But if we consider the case of hyperbola, the distance traveled will be much greater. So in this case, you can see it is beyond sort of a throw. This is why we call it a hyperparabola. Yes, we can say it is similar to parabola, but not exactly the same. And in other words, we can say that it is wider than that of a parabola. Now you can see that this diagram is likely to have asymptotes as well. Let me show you this diagram, which is visible. Actually, it's an economic example, the aggregate demand function, which is very famous, and it is applied and used in macroeconomic theory. Now, it has two asymptotes. One is visible with the vertical axis and the other is visible with the horizontal axis. Now, coming to this diagram, as you can see, on y-axis we have price level and on x-axis we have national income. And the diagram, as you can see, is likely to have two asymptotes, and it is not a straight line, because assuming that it is a straight line would be oversimplification of the real life world, because linear relationships, they are not necessarily occurring in the real world, because real world is quite complex as compared to our economic models. So you see that this sort of curve is used in economic applications. There are other applications as well. Let us see. You can see that in this diagram, this rectangular hyperbola is having the same sort of properties. It is having two asymptotes. However, it is showing a microeconomic relationship. On x-axis, we are having quantity, and on y-axis, we have plotted the price. And again, the relationship is showing the curve which is similar to that of a rectangular hyperbolic curve. However, there is a caveat. And this caveat is that this is that demand curve which is having elasticity of demand with respect to price equal to 1. As it is visible in this slide that the value of the elasticity of demand is equal to 1 at all the points. So this is that unitary elastic demand curve, and it follows a rectangular hyperbolic curve. Now we shall consider a certain version of hyperbolic functions. It is known as the rectangular hyperbolic functions. And as you can see in the diagram, it is having a sort of shape which is similar to the vertex of a rectangle. Though the vertex is not having a kink, it is round. However, we can say that it is a special version of hyperbolic functions which is having the shape which is well known as rectangular hyperbolic function. Now we come to the standard form of it, and that is it uses two variables, that is the dependent and independent variable x and y, and their product is equal to a constant. As you can see that the value of k is actually a constant, and their product yields a constant value, that is x into y. Now there are two possibilities. Either this constant is a positive constant or a negative constant. If it is a positive constant, the diagram would be just like the upper diagram, that it is occurring in the first and the third quadrant. Whereas if k is less than 0, the second diagram would exist, and that would be the existence of two curves one in the second quadrant and the second in the fourth quadrant. So this is how the rectangular hyperbolic functions exist, and the economic applications that we shall see will be based on the rectangular hyperbolic functions.